So, you've come back for another Tips for the Trades podcast. Welcome. I'm Jeremy Lowe, Senior Director of Content and Training at Service Fusion Business Academy and an Associate Trainer at Service Nation. And normally, this podcast is about tips for running a more successful, easier to run, and profitable service business. But you know what? I'm going to go totally off the rails, so to speak. While learning how to run a profitable business and making your business easier to run is great, I thought it'd be interesting to take a dive into the history of some of the service trades, how they got their start, and the profound impact that those inventions, such as heating, air conditioning, electrical, plumbing, locksmithing, has had on the world and the environment. And if I receive good feedback from this episode, which will start with HVACR, we'll continue into some of those other trades. Now, if you're not a history buff like me, this podcast may not be as interesting as one that deals on some of our business-related topics. But if you'll take the time to listen, I think you may find a lot of things out that you might not have known or perhaps heard of but didn't know all the detail that you may be able to use in your advertising or in your discussion with your customers. But let's start with the coolest thing of all, HVAC. Did you see what I did there? The whole coolest thing of all? All right, never mind. I'm a history buff. And so over the years when I sold air conditioning and managed air conditioning companies, I always heard that Willis Carrier was the father of air conditioning. And while I knew that there were other people involved, I never knew who and how the progress of heating and air conditioning came from the beginning of time all the way up to our date today. And even though Willis Carrier was hugely instrumental in putting air conditioning in the common home and common business, I want to start our history lesson back in 2500 BCE, over 4,000 years ago. You see, in the sweltering temperatures back then of the Nile Valley, the Egyptians would toil in that terrible heat, building monuments like the Great Pyramids and digging monumental tombs, things that still stand to this day. However, they weren't just great builders. They were also very innovative engineers. I mean, think about it. If someone can move chunks of rock that weigh tons and fit them so closely that in some cases a sheet of paper can't even fit in the joint, they were pretty good engineers, right? But ancient hieroglyphs talk of slaves taking clay pots in the morning to the Nile River to draw water and carry it back to their home so they could soak mats made of either river reeds or cloth in the pots. Now, once these mats were thoroughly soaked, they were then hung over windows. And here we have the first recorded evaporative coolers. Of course, the hot, dry desert air lent itself to this, and as it blew through these covered windows, the temperatures dropped. And evaporative cooling then progressed in that arid region to become more widely used, and it's been, for centuries, used as an effective tool in lowering temperature in businesses, homes, and keeping occupants cool. Perhaps you've noticed at a football game, big machines blowing mist on the sidelines. Guess what? Evaporative coolers, affectionately known by some as swamp coolers. Primarily only effective in very dry climates. Keeping occupants cool with wet mats over the windows back in 2500 BCE wasn't the only method ever used to cool homes till the invention of air conditioning. The Chinese expanded on this concept of evaporative cooling when in the 2nd century BCE they invented the first ever rotary fan. An impressive 10 feet wide, 7 wheels were powered manually by prisoners, moving air, and in 747 the emperor had a cool hall built just to use this large rotary fan concept. But this time, he powered the fan with water instead of humans, and blew air through rising jet streams of waters that shot from the fountains in the hall. It's interesting that the Chinese were also the first to record having a beverage cooled with ice. Since 1100 BCE, records exist of the imperial court having an official drink preparer who is responsible for maintaining ice to keep the emperor's drinks cool. All of this in an attempt to create some relief from summer heat. Now, back then, the ice was brought in from outside sources. It wasn't made, but that would change in the near future. Now, the Romans routed aqueducts, pipes with running water, through the walls in their home, using that cool water to evaporate and lower the surrounding temperature in rooms. And in Iran, which was once the kingdom of Persia, buildings were often constructed with what's known as wind catchers. What's a wind catcher, you ask? It was a large turret or capped tower that rose higher than the home. It had an open side positioned to catch the prevailing wind, kind of like a scoop, wind catcher, and direct it down into the building to provide ventilation. Air would move through the building, exiting on the other side, providing cross ventilation and preventing stagnation of air. Now, it really didn't cool, but it did give a measure of comfort by keeping the air moving. And in the future iterations of it, they designed on the opposite side of the tower that caught the air an exit for the warmer air through what we all today know as stack effect. The wind catchers of later centuries used in Persia were an improved version. The air was sent from a wind catcher down to an underground chute under the floor, running the length of the building and exiting on the other side at a similar tower. Forgive me if my pronunciation is wrong. Maybe somebody can tell me exactly how this is pronounced. But these bagdirs, as they were called, allowed air to be drawn in at an opening facing away from the prevailing winds. Now, how does that work? Through a Venturi vacuum effect at the tower opening. It sucked the hot air into this underground chute spanning the width of the building. The air was then drawn across cool water brought in a canal under the home known as qanats, drawing away the heat. Through the principle of evaporation and convection, the homes were cooled. When the cooler air was discharged into the home, then exiting on the opposite side of the wind-catching tower, again through stack effect of rising hot air. It could at times lower the temperature by 10 degrees, which was a huge accomplishment in the desert heat. It was this ingenuity that allowed desert villages along the Silk Road in the 14th century to enjoy a measure of prosperity as traders knew that they could find places that would be naturally cool, both places to eat and to sleep. And just think, all of this without the use of electricity or motors. Even the American Indians utilized a variety of construction methods to keep their homes cool, from the traditional teepee that allowed natural ventilation through the stack effect, to dwellings dug into the cooler earth or raised on stilts to allow air to pass around and under the dwelling. Summer homes were usually set up near lakes and rivers to allow frequent dips so one could cool off. Western settlers in the 1800s would actually soak their bed sheets and sleep under their sheets or soak their bedclothes to take advantage of evaporative cooling. Now, if you grew up anywhere in the south part of America, where I did, you will have probably heard of a cracker home. This was a home that was built typically with kitchens that were detached from the main home as a separate building, but spanned with a common roof to the rest of the home. A breezeway ran between the kitchen and the house, preventing the heat from cooking or the fireplace from radiating into the home. It also enjoyed the added benefit of, if the kitchen went up in flames, which often happened, keeping that highly flammable cooking area separate from the rest of the home so that the whole house didn't burn, only the kitchen. In fact, some early settlers simply slept on that porch when it was too hot to sleep inside. Many homes built in the 1900s were purposely narrow and deep, with doors at the end of a long hall running the length of what some call shotgun houses, as they were affectionately known. This was actually an adaptation on togan, the African Yoruba word meaning house or gathering places, and as were indicative of African design of dwellings made to encourage a breeze through the structure from front to back with no obstruction. Of course, having narrow property also made this an attractive home, but they were designed with high ceilings and what were known as transom windows, windows above the doors to room that could be opened to allow rising heat to escape the room to the hallway where it was then carried away with the breeze, increasing the comfort of the occupant through natural ventilation. However, beside these natural ways to keep cool, another approach to scientifically and mechanically keeping buildings cool was emerging. And it all started with someone you may not realize, one of the founding fathers of America. In 1758, Benjamin Franklin and a chemist professor by the name of John Hadley discovered that certain liquids applied to a mercury bulb thermometer would cool the thermometer as they evaporated. Now, this wasn't a newsflash. We knew that evaporative cooling worked. But as they experimented with various chemicals, they found that some were able to lower the temperature from 64 degrees Fahrenheit all the way down to 7 degrees, providing the chemical principle behind highly evaporative chemicals. Sadly, nothing more came of their research until 1820, when Michael Faraday, believe it or not, the father of the Faraday magnet, the electrical generator, and known for having measured the ability of a capacitor to store charge, which we measure in farads. Boy, that's a lot of information there, but he found that if you compressed ammonia from a gas and turned it into a liquid, when that liquid later evaporated, it would chill the air inside a room, and thus the principle of gas compression and liquid expansion were developed. In 1834, it was an American who had moved to Great Britain, Jacob Perkins, who built the first working vapor compression refrigeration system in the world. He built on Oliver Evans and Michael Faraday's principles of the refrigeration cycle. It was based on vapor compression using ether. Sadly, it just put everyone to sleep. Okay, I know, more bad humor. I guess I need to fire the scriptwriters. But it's interesting that it was in 1834 that the concept of a refrigeration system was born. And perhaps if you ever grew up in Florida or studied the history of Florida, know of Dr. John Gorey, who's the real father of refrigeration. As a doctor, he was trying to bring comfort to his yellow fever patients and lower the temperature of the air around them by creating ice that he could blow air over for air conditioning in 1844. You see, Dr. Gorey believed that providing cool air to his patients burning up with fever would not only bring relief, but could speed up their healing process as well. Well, the problem was, look, Florida's a long way from the ice fields in the north, so ice was slow to arrive, a lot of it melted, thus it was limited in availability and extremely expensive, so he just said, hey, I'll create my own ice. He used a small steam engine to reduce the temperature of compressed air by interjecting a small amount of brined water into it and circulated the water through submerged coils to make a pan of ice over which to blow air so that his patients suffering from that tropical malady could be more comfortable and cool. Dr. Gorey called this invention an ice machine. This was the basis of new machinery that would produce cool temperatures. Seemed like an exciting proposition during the Industrial Revolution, but sadly, Dr. Gorey's efforts to actually take that from patent to production were thwarted. You see, this great concept would have to be mass distributed, and Dr. Gorey worked long and hard to get a patent, and if you've ever tried to get a patent, you can imagine how hard it is. In 1851, he got a U.S. patent on his ice cooling apparatus, but unfortunately for John Gorey, his plans of manufacturing and selling his invention were met with fierce opposition by one Frederick Tudor, the man known in Boston as the Ice King. We can blame Frederick Tudor for how long it took air conditioning and refrigeration to really reach the American market. You see, Mr. Tudor, at that point, as the Ice King, was shipping ice from the north part of the United States all the way to Cuba, and he was planning on expanding even into India. But you see, Dr. Gorey's invention would ruin his business, so what did he do? He began a smear campaign against the inventor. After struggling with Tudor's savage disinformation campaign, built on the platform of all his distribution companies that Frederick Tudor owned, sadly, with the death of his partner, Dr. Gorey also died, both bankrupt and humiliated, and it seemed at that point that the future of HVAC and refrigeration for ice was in jeopardy. But there were several determined inventors that refined that concept Dr. Gorey had built, and in 1870, several commercial companies specializing in conditioning air through ice and evaporation began springing up to develop this emerging technology for larger buildings like hospitals and schools. It just seemed like the future of keeping cool was tied up in the hands of frozen water. An early ASHRAE journal on the history of refrigeration made these comments. A demand was arising for central systems that would provide refrigeration for breweries, ice making, and cold storage. Central heating and ventilation plants were needed for various buildings being constructed. However, there was little demand for comfort cooling. At the time, mechanical refrigeration was just too expensive to be used in this fashion. But then again, ice also was very expensive. In his 1873 article on the various methods of cooling the air, A. Juglet, a well-respected engineer, discussed using ice as a means of comfort cooling, but concluded, in point of fact, this method of refrigeration must be considered impractical. While ice is not very cheap and cold cannot be produced as inexpensively as heat. Well, it was about that time that the production of ice and the cooling of objects to a freezing point gained the name refrigeration and suddenly went through a rapid development. Thaddeus Lowe, I gotta love that in the last name, Lowe. Sadly, we're not related, but he did develop a method that utilized the cooling effect of expanding gas. Again, building on the previous principles of Faraday, he built this expanding gas system to remove heat and refrigerate a space. With his findings, he invented a carbon dioxide-cooled ice-making machine. Then, a U.S. patent for an ice maker was awarded to Alexander Twining in 1853. Just like Thaddeus Lowe, Twining used vapor compression to harness the cooling properties of expanding gases. He's credited with creating the first commercial ice machine in 1856, a year after the father of ice machines, Dr. John Gorrie, died, thinking his invention was a failure. Now, simultaneously, advances were being made all across the world. In Australia, where James Harrison was successfully building a refrigeration machine capable of producing 3 tons of ice per day. And in 1855, he received an ice maker patent in Australia, similar to that of Alexander Twining. Harrison continued his experiments with refrigeration, and today he's credited with major contributions to the development of cooling systems, their designs and functionality, and the strategies used in implementing them. In fact, the systems he designed were later used to ship refrigerated meat across the globe. But the real breakthrough in commercial refrigeration came in 1876. Carl von Linde, a German engineer, introduced the process of liquefying gas, which is a fundamental part of most refrigeration systems today. Now, you have to understand the theory already existed, but the practical application had not yet been found. It would be another decade after Carl von Linde invented the complete process of liquefying gas before it was practically applied in the heating and cooling systems. Now, it's at this point that the path of cooling air and cooling things, or refrigeration, diverged and went separate ways. In 1879 and 1891, respectively, 2 African-American inventors, Thomas Elkins and John Standard, both patented improved refrigerator designs, moving home refrigeration one step closer to realities using these principles of liquefied gas and gas expansion to create lower temperatures. It was in 1880 that in New York's Madison Square Theater, 4 tons of ice were used to cool patrons at evening summer performances. Fresh air was filtered through a 40-foot-long cheesecloth bath, passing over wooden inclined racks containing 2 tons of ice, then into an 8-foot diameter centrifugal fan. The fan discharge was then directly put over another 2 tons of ice, then into ductworks with various openings through which the cool air could pour into the house, reducing the temperature and furnishing a supply of cool comfort. Now think about this, folks. How do you think those 4 tons of ice got on those racks? It was people labor. Trust me, I'll never again complain about lifting a 30-pound jug of refrigerant. It was at this point, after 1880, that the frequency of companies offering to engineer, make, and install heating and ventilation were popping up everywhere. The technical staffs at these companies were the newborn in a new profession, the leading pack of engineers that would soon become ASHRAE, founded in 1894. Yet it was still ice that was used to relieve the suffering of U.S. President James Garfield, who lay dying from an assassin's bullet in the summer of 1881. Naval engineers passed air through dozens of thin cotton screens onto which dropped cold meltage from salted ice gas in a mixture contained in a tank above. The cool air was then ducted into the president's bedroom, reducing the temperature as much as 20 degrees Fahrenheit. And although Garfield would die, it was another step towards commercial cooling. It was, sadly, the first time a U.S. president had ever been cooled. By the early 1900s, a science of comfort and cooling was beginning to evolve. You see, the effect of humidity on human comfort was becoming better defined. And the understanding that the basis of how people experienced humidity and temperature could personally change the way the air felt. In other words, the feels-like temperature. The relationship of humidity to temperature and the means of measuring it and the control of it became topics of intense study and discussion. And by the turn of the century, the control of humidity in a building became a higher standard than the control of temperature. It was in 1901 that Alfred Wolff designed the HVAC system for the New York Stock Exchange. And in 1902, a young 25-year-old engineer by the name of Willis Carrier designed the system for the Sackett-Wilhelms Lithographing Company, whose building was so hot and humid that the ink would run on their printing presses, smudge, and not dry properly. And they turned away from ice cooling and adopting that process because it didn't give them the ultimate control over humidity, which really, in the printing company, was the biggest issue, not getting cool air. Now, as I stated when we started this conversation, Willis Haviland Carrier has become known as the father of air conditioning, and he was instrumental in bringing HVAC to the masses and employing different methods to achieve indoor comfort and humidity control. From 1902 to 1915, he was the chief engineer of the Buffalo Forge Company in New York, where at the age of 25, just out of college, he had invented that first electrical air conditioning unit used in the printing company. This printing company, suffering extraordinary monetary losses due to excess humidity, led Carrier to propose a system that would control not just temperature, but humidity and air circulation and ventilation and the filtration or cleansing of the air. Through a series of experiments, Carrier designed a system that controlled humidity using cooling coils and applied for a patent for his apparatus for treating air, which could either humidify by heating water or dehumidify by cooling water. As he continued testing and refining this technology, he also devised and patented an automatic control system for regulating humidity and temperature of the air in textile mills, and became acquainted with one Stuart Kramer, a textile magnate. Stuart had coined the term air conditioning when he had installed a system to mix water with air to condition the air in his textile mill. Willis liked the moniker of air conditioning so much that he put it behind his name after he broke off from Buffalo Forge, and along with 6 other engineers, he formed the Carrier Air Conditioning Company on June 26, 1915 in Syracuse, New York, and the rest, they say, is history. Well, modern air conditioning was born, but even after this plethora of advancements and innovation in refrigeration and heating and cooling, there were still more advancements to be made. Inspired by how ineffective her fireplace during the cold New Jersey winters, an inventive African-American woman by the name of Alice H. Parker invented and patented in 1919 a heating system that drew in cold air and conveyed the heat through a heat exchanger. Now, during her time, most buildings were heated with coal or wood and boilers, but while her invention was not the first gas heating patent, it was the first to feature individually controlled air ducts that transferred heat to different parts of the building, making her, in effect, the mother of ducted heating. In 1922, Carrier brought his technology to theaters when he debuted his new chiller technology, and shortly after, the first home air conditioner was designed, but sadly it was way too expensive for adoption, except by the wealthiest of homeowners. And it would still be another 30 years till air conditioning, as we know it, HVAC, really took off in the 60s and then became mainstream. But the progress of heating and cooling across the country was slow. Now, the history lesson isn't done. I know, I'm babbling, but this to me is fascinating. More technology involving the use of refrigerant gases expanded after Carrier formed his company. Now, the ice machines from the late 1800s to the 1930s used toxic gas such as ammonia, methyl chloride, and sulfur dioxide as refrigerants. Nasty, nasty things. And during the 1920s, there were several fatal accidents. So the driving desire to replace these refrigerants, especially methyl chloride, brought together two inventors, Thomas Midgley Jr. and Charles Franklin Kettering, who created in 1928 a chemical they affectionately named Freon. Within a few years, Freon became the standard refrigerant as it eliminated many deaths and avoided toxic chemicals from years back. It was in 1930 that General Motors and DuPont formed Kinetic Chemicals to mass-produce Freon, what we affectionately know, or knew I should say, as R22. Much later, this became the standard for almost all consumer and industrial refrigerators. A hydrochlorofluorocarbon, or HCFC, a refrigerant commonly used in air conditioners from the 1960s to about the mid-90s, when it began to be replaced by refrigerants considered more environmentally friendly. One of them, affectionately known as R410A, now today also considered a destructive gas and in the process of being phased out. After World War II, when America became proficient in mass production and the goal was for every person to own their own home, air conditioning became popular. The price dropped and its expansion was rapid across the country, starting first in the hotter areas such as Arizona, New Mexico, Texas, California, and Florida, but rapidly spreading northward. The technology that was initially envisioned as a tool to enhance industrial productivity is now a necessity for American homes and for the transportation we move about in. It's interesting to note that the Smithsonian Journal reports that today, a U.S. household is more likely to have central air conditioning or window unit than it is to have a dining room, garage, or even a dishwasher. Nearly 90% of U.S. homes have air conditioning. Though humans in hot climates around the world have cooled themselves with fans, fountains, and natural ventilation systems for centuries, it's only the U.S. that consumes the most amount of power in the world, more than the rest of the countries in the world combined. In fact, in 2020, the United States consumed 254 billion, with a B, kilowatts of electricity for air conditioning, and it composed 19% of all household utility consumption. Today, with the HVAC industry projecting a 4% growth over the next 5 years, even more of these technologies that we just traced will not only be used, but will be innovated on. Current technology is evolving at a frantic pace in the HVAC industry, from not just units that cool, but units that talk, units that self-diagnose, units that provide the ultimate in indoor home comfort and in indoor air cleanliness. But we can all thank the forefathers of air conditioning and refrigeration for bringing us to where we are today, by having a passion for learning, a desire for innovation, and their insatiable curiosity, which brought about the changes that developed our industry and today are making things better for humanity. And listen, trust me, as a boy who grew up in Florida without air conditioning until I was 18 years old, I can tell you with a certainty, no one should take this fantastic technology and the lineage of revolutionary developments all the way back to the Nile River and Egypt for granted. Well, I hope I didn't bore you to death, and thanks for coming along on this jaunt through history. If you enjoyed it, drop me a line or leave a comment, and maybe we'll do another one in the future. But our next podcast will return to business principles. So until next time, this is Jeremy with Service Fusion and Service Fusion Business Academy, and also I enjoy training at Service Nation as well. As always, I encourage you to look at our award-winning workflow management software, Service Fusion, designed not only to make your companies easier to manage and help your profits grow, but to be a software program that runs the way you run your company, not the way the software company tells you it should run. Used by over 8,000 companies today, come see why Service Fusion is making waves in the software industry. Also, definitely encourage you to visit Service Nation's website servicenation.com. Even if you're not interested in a lot of training classes, you should be interested in learning the best practices that the most successful companies with the highest dollar value use today to grow their businesses. You should also be interested in leveraging over $1 billion in combined purchasing power to basically pay you rebates on the things you most often use. And hey, I also can brag on the training, not just because I'm involved, but because of the great amount of people that come to train that have walked the walk, talked the talk, built huge mega $1 million companies that they've sold, and now they're willing to give back their knowledge and their business. And you can share this information with a host of other contractors from across the country by simply signing up at servicenation.com. I'm going to guarantee you it will be one of the best decisions you've ever made. So stay tuned for our next podcast. And if you like tips for the trades, and hopefully the history one as well, then tell your friends and encourage them to subscribe as well. Now go out there and build something great. This is your trade, your business, and your legacy that you should be proud of. Think about how long it took heating and air conditioning to come to the point that it is, and just how exciting the technology and science behind it is today. But remember, in the trades, every small improvement you make in your business adds up to big results. So keep yourself educated, learn, and until next time, keep your businesses growing, keep them efficient, keep them profitable, and keep striving to make your business the best it can be. This is your Tips for the Trades, signing off.